Okay, so in the last session we learned equations of motion. First equation of motion, second and third. These are the names, not just the numbers. These are the names of these equations. So first equation of motion, second equation of motion, and third equation of motion. Putting together these equations deal with 5 variables. Initial velocity, final velocity, acceleration, time, displacement. So 5 of these. And each equation deals with or connects 4 out of these 5. For all the kinematics problem, what you have to do, you have to find out known plus unknown, 4 of these variables. And then you can check what equation can you use. So today we are going to solve some problems, and I need you all to participate and focus and answer as fast as you can. So let's start solving the problem. Let me grab this first because you should have this information. I don't expect you to memorize that. Step 2. Okay, screenshot taken. Here, copy. Okay, now let's start solving the problems. Solve this problem. A car is moving with velocity 5 meters per second. After applying brakes, it comes to rest in 5 seconds. Find acceleration. And first of all, you need to find out what equation is going to help you. I have already marked the variables that are involved here. So pick the equation and give me the answer, please. No answer yet? This is one of the easiest question. Okay, let's start solving it. So we have, sorry, maybe I missed. Have you explained what these equations are before? Yes, in the last session, I did. Did you attend the last session or not, Stephen? Okay. Yeah, so I just introduced these equations a bit. Yeah, please go through the session. So here what we are going to do, I'll try to just walk you through all this technique one more time. So first of all, read the question and try to find out these 5 variables. We will be able to find 4 of these, known plus unknown. So a car is moving with velocity 5 meters per second. So okay, this is where our scope starts. This is where, as an observer standing outside of this problem, not being in the car, you are looking at the car, you have a stopwatch in your hand, and you start observing and making these measurements or collecting information, whatever. So this is where your scope starts. The car at that point is moving at velocity 5 meters per second. So that is the initial velocity. Okay. So okay, let's see. So VI is equal to 5 meters per second. Okay, now keep reading. After applying brakes, it comes to rest. When we say it comes to rest, of course, it is telling you something. It means that the final velocity is equal to 0. Vf is equal to 0, exactly. So Vf is equal to 0 meters per second. Now, in 5 seconds, so from the time you saw that, you noticed that the car was running at 5 meters per second, and right there it applied brake, and within 5 seconds it came to rest. So the time during which all this happened is 5 seconds. So the time for this problem is equal to 5 seconds. Very good. So find acceleration. Acceleration is what we need to find out. So now you don't need to even worry about the solution at this point. The first stage is to find the variables. So we have 4 variables. Out of these 4, 3 are known, 1 is unknown. Perfect situation, because if there are 2 unknowns, you cannot use the equation. Okay, it has to be just 1 unknown. So VF, VI, A, and T. Now you have to figure out what equation involves all these 4 variables. Because it is first, so I'm going to begin with the third one. So the third one, A, okay, A is over here. S, no, we do not have S. On the other hand, VF, VI, fine, but this does not have T. So this does not really get along with this problem. So third equation is out. Why VF is equal to 0? Because it comes to rest. When it comes to rest, it means it stopped. That is where our observation stopped. That is where we stopped noticing the car. Okay? That is where our scope closes. Is that clear now, Stephen? Okay. Now, the second equation of motion, it involves S again. S is something, is element here. We don't really need that. So again, out. First equation of motion, VF, VI, A, T, VF, VI, A, T, perfect match. We are going to use this. Okay, good. Now, let's solve it. Let me push this up a bit and put the values here. So VF is equal to VI plus AT. Just plug the values to begin with. VF is equal to 0, is equal to VI is equal to 5, plus A, acceleration, we don't know that. Time is 5, okay? So, now just rearrange. Subtract 5 from both sides. So you'll have 0 minus 5 is equal to minus 5, and 5 plus A5 minus 5, 5 cancelled out, and you have A5. So it will be, let me start another text box here. Okay. Copy, paste. So we have minus 5 is equal to A5. And now divide both sides by 5, and you have A is equal to minus 1 meter per second square. Now, as I said in the first session, not first session, but first kinematic session, that you'll be solving the problem mathematically, but you have also you have to make sure that it makes sense physically. Now, minus 1 meter per second square. Meter per second square, not meter square. It is meter per second square. That is the unit of acceleration. It is meter per second, change in velocity per time. Okay. So, minus 1 meter per second squared suggests that something is slowing down. Negative acceleration essentially means that something is slowing down. Positive acceleration means something is speeding up. So here, A is equal to minus 1 meter per second squared. Does it make sense physically? If you read the problem, yes, it does, because the car was moving at 5 meters per second. It applied brake. It is slowing down, decelerating exactly. It took 5 seconds to come to rest, so it was slowing down. So if it is slowing down, it means that acceleration has to be negative, and that's what we got in the numerical problem, the mathematical tackling of this problem. So when you are solving these problems in practice question sets, in quizzes, in exam, make sure that you go both ways. You solve the mathematical problem and then you try to make sense of it. Does it make sense? If you understand the problem, and I hope you do, then you should know right away that, okay, the acceleration has to be negative. It cannot be positive in this situation. And for some reason, if you are getting a positive answer, the alarm should go off that something is wrong in the calculation. You need to go back and check the calculation. Okay? So this is one way to avoid any mistakes. Now let's solve this one. Again, you have the variables highlighted. Please solve this problem. No answers yet. Okay, let's start solving it. Okay, let's see. A stone initially at rest. So that's where your scope begins. That's where you started paying attention to this problem. A stone initially at rest. At rest means the velocity is 0 meter per second. But what velocity is that? You just started noticing that, so it has to be initial velocity. So Vi is equal to 0 meter per second. Okay. Second thing is dropped. When something is dropped and allowed to fall freely, the acceleration is g exactly. A is equal to g because it is coming down. Its velocity is increasing with every passing moment. So it means that acceleration will be positive, not negative. If you throw something upward, the acceleration will be negative. And exact value of g is gravitational acceleration, and that is the acceleration at which is involved in all the falling bodies for Earth. For other planets, for other objects in the solar system and outside, the value of g may be different. Okay, so for Earth, g is 9.8 meter per second, but for physics 1 and physics 2, we keep it simple, 10 meters per second squared. Now, if you use 9.8 meter per second squared, you may not be able to find the option that is in the exam. So make sure you use 10 meter per second squared, not 9.8 meter per second squared. Okay, so A is equal to G is equal to 10 meter per second squared from 50 meter height. So during the scope of our problem, the object, the stone, has to fall through 50 meters height. So S is equal to 50 meters. How long will it take to reach the ground? So time is equal to, you make sense, let's see. Time is something we don't know. We need to figure out. So what equation involves V, I, A, S, and T? Please answer quickly. Hurry up. All of you. Okay. There is no middle. It is second equation of motion. It has a name. Okay. Oh, sorry. My mic is moving. Let me set that first. Okay, here we are. So yes, the second equation of motion can help us because it involves S, V, I, T, and A, all good. So let's start solving this. Change font size. So S is equal to V, I, T, half or 0.5, whatever you like, A, T squared. Now just plug the values. S is 50 is equal to Vi is 0, so Vit will be 0. We don't need to waste our time on this term. Plus half multiplied by acceleration is 10 multiplied by T squared. T is what we need to find out. So now let's simplify this a bit and clean it up. 50 is equal to 0 drop. 1 by 2 multiplied by 10 is 5, and T squared. Okay, so we get T squared is equal to, divide both sides by 5, you have 10, and T is equal to square root of 10, that is 3.16. Okay. Any question or confusion? So far, I'm not getting the response I like to get, because these problems should not take too much time. The first step is to identify variables. Second step is to identify the equation. That should not take more than 20 seconds complete, and then solve it 30 more seconds, and within a minute you should have your answer. So please try to do it quickly and focus. This is the problem, but let me give you a hint first. Find the maximum height it will reach. The clue here is its final velocity will be 0 at that point. When you throw something upward, it goes, and at the final point, it stops for a bit and then starts falling down. So that's the clue. Solve the problem and let's see. Sorry. We are trying to find maximum height. It cannot be meter per second squared. Do you mean meters? Okay. We'll see. I have two answers so far. Okay, let's solve it. So first thing, variables VF, VI, A, and S. First equation does not help. Second, no. Third is what we need. 2AS is equal to VF squared. Kusika, you are again not showing much respect to the names of the equations. So these are first, second, and third equations of motion. Okay. So yeah, they mind. Yeah. Okay. Now. Okay, so a stone is thrown straight upward. So if we throw something upward, one thing is understood that A is equal to minus G, that is equal to minus 10 meter per second square. So this is the kind of information you should be able to grab from the statement. Now, with initial velocity of 100 meter per second, so VI is equal to 100, not 1000 meter per second. Find the maximum height. When you say maximum height, it means that you need to find out S, but it will reach. It means that, as I gave you the clue, that VF will be equal to 0 at that point. So VF is equal to 0 meter per second. That is the characteristic of the highest point. Now let's solve it. So again, as we have already figured out, the third equation of motion, 2AS is equal to VF squared minus VI squared. Just plug the values. A is minus 10. I hope you did not forget negative sign here. Multiplied by S, we don't know, just like it. And VF squared. What is VF? VF is 0. So 0 squared is equal to 0 minus VI squared. VI is 100. So 100 squared. Okay. So now let's solve it, and first let's do some cleanup. Minus 20 multiplied by S is equal to minus 10,000, and negative, multiply both sides by negative 1 minus 1, and you get 20. S is equal to 10,000, and S is equal to 500 meters. Very good. Okay. So this is how you solve the problems, and typical method. First, read the statement carefully, identify the variables, find the equation, plug the values, and you are good. Let's solve this second problem. A car accelerates steadily so that its velocity changes from 20 meters per second to 40 meters per second in 4 seconds. What is the acceleration? Forget about this part for now. Okay? You guys got confused yesterday, so I don't want to do that again. Solve it, please. Here. This is very simple. Sorry. Yes, exactly. First equation of motion is derived from that definition of acceleration. Yeah, but you can use just equation of motion just fine. You don't need to worry about the definition of acceleration. But the formula is correct, what you just wrote down. Okay. Good. Last offer. Okay, let's check. First of all, let me tell you the relation between the first equation of motion and acceleration. Acceleration, that is not the solution. I'm just discussing something. So acceleration is A is equal to Vf minus Vi divided by T. Now, if you multiply both sides by T, we have At is equal to Vf minus Vi. Now, I add Vi on the both sides and rearrange that. So we have Vf is equal to Vi plus At. That is exactly the first equation of motion. So it is directly derived from the definition of acceleration. Now, let's solve this problem. We have the last offer, minus 5 meters per second. So let's check how good is that, if we can accept that. So a car accelerates from 20 meters per second. So we have Vi is equal to 20 meters per second, and to 40 meters per second. So Vf is equal to 40 meters per second, and in 4 seconds, so time is equal to 4 seconds. Now you can see how easily we can understand the scope. Just imagine yourself as an observer watching all this happening, and it will make perfect sense to you. And we need to find out acceleration. So Vf, Vi, A, and T all together in first equation of motion. So let's use that. Vf is equal to Vi plus At. Isn't that too small? 18. Okay. So just plug the values. Vf is 40 is equal to Vi is 20 plus A is we don't know, and T is 4. Subtract 20 from both sides and rearrange. A4 is equal to 20 and A is equal to, divide both sides by 4. A comes out to be 5 meters per second square. Your last offer is accepted. Good. Okay. Finally. Okay, now let's solve the second part of it. Wait a second. We had a value of acceleration, yes. A is equal to 5 meters per second squared. This is another piece of information we have from the first part, and now let's solve the second part. And this time I'm going to black this one out. Now solve this. How much distance did the car cover during this time? to give you a hint, you can use two equations here, depending on if you want to use A or not. Okay. Okay, let's solve it. First of all, as I told you, we have two choices. We can use second equation of motion or third. So I don't really like third equation of motion because two squares I don't like to deal with. So let's go with the first equation of motion. And also it is giving us S directly, so why not? S is equal to, but if you use second or third, the answer will be the same because situation is the same and the value does not change with change in equation. So S is equal to VIT plus half AT squared. Just plug the values. S we don't know. VI is 20, not 2. Sorry for that. Let's fix it right away. Okay, 20 and multiplied by what is time? 4 plus half multiplied by A. A is it was 5. Okay, multiplied by T squared. 4 squared is 16. So S is equal to 20. Multiplied by 4 is 80. Okay, good. Plus 8 by 5 is 40 is equal to 120 meters. Good, very good. It's okay, no problem. Again, the whole point is that you make all the mistakes here so that you don't do that during your exam or quiz. Let's, just for the sake of fun, let's solve this with the third equation of motion as well. Usually I ask students to do that using third equation of motion, and I know for sure that you are not going to do that, so let's do it here. S is equal to VF squared minus you ran out of money? VI squared. So, okay, now 2 multiplied by, what is the value of A? It is 5 multiplied by S, we don't know, is equal to VF squared. VF is 40, so 40 squared, 4 by 4, 16, 0, 0, minus VI squared. VI is 20, 20 multiplied by 20 is equal to 400, so 10S, is equal to 1600 minus 400, it will be 1200. Actually, this is the easier method. and when you simplify that, divide both sides by 10, S is equal to 120 meters. Awesome. Okay, now application of kinematics in life sciences. I'm really not in the mood to discuss all this because it will not be the part of your exam, but because it is an application in the life sciences, so please go through that, okay? Try to understand what's going on. The whole problem is divided into 3 parts, and you can see how you apply these equations on the problems related to life sciences actually happening there. So let's go through all this, and I'm just going to discuss this for last slide with you. So after all that discussion, what we'll find out is for a person with 70 kilogram mass, the weight will be 686 Newton. Making an exception here for the sake of accuracy, I'm using G is equal to 9.8. Okay, and the work done is 411.5 joules. You have not learned what is work. Work is basically force multiplied by a dot product with the d, the displacement along which the motion happened. So here the important concept is to understand the difference between the work done and the chemical energy, the energy dissipation. For example, if I am pushing against the wall is not moving. So physics says that there is no work done, but my body is getting heated up. My body is consuming energy. So these two things you should be able to differentiate. So that is the topic of these 2 slides. Again, skip it and get to angular motion. So far we have been dealing with motion along straight line. The life was very easy. Now it's going to get a little bit complicated. Angular motion, circular motion. So again, the simplest topic will be the uniform circular motion. Something is rotating, like Earth, Moon around Earth, Earth around Sun. Of course, these are not circular orbits, but just an example. Motion of a particle on a circular path of radius r with constant speed v. So here you will understand that the linear velocity is not the only thing that is important here. We need to talk about the tangential acceleration as well, and there are 2 kinds of forces involved, and that will help you understand how the satellites move around Earth. That will be the fun part of it. So centripetal acceleration. Centripetal means the attracting towards the center. That is always perpendicular to the velocity v. So at any object, if you attach a stone or any object to a spring and you start rotating that, not a good idea to do that at home, but when you don't have anyone nearby to hurt, so do that. The stone is moving along a circular orbit, and if you release that string at any point, at any instant, the stone will move in a straight line, leaving the orbit, and it will go along a straight line. So what did really happen? At every point, the linear velocity of the stone is the tangent at that point. Now the question is, what is tangent? The tangent is the perpendicular to the radius at that point. So for example, this is the center, and a line drawn from here, the dotted line, this is the radius, right? So if I draw a line that is at an angle of 90 degrees with this radius, that will be the tangent. Okay? So this is the definition of tangent. and that's where the word tangential comes from. So that when you release the stone at any moment, it goes along this tangent. This is what happens. So perpendicular or tangential acceleration or centripetal acceleration, to be specific, is equal to v squared over r. Where did it come from? We don't need to worry about that. Period or time period tau. Tau is a Greek letter. It's the time for one revolution. Now the thing is, we know that velocity is distance divided by time, or displacement divided by time. Here, because the direction is changing at every point, so we can say that it is actually speed, or if you want to keep it velocity, you should understand that the direction is changing at every instant. So what is the total displacement during this during one revolution? That is 2 pi r. That is the circumference of the circle of radius r. What is circumference? If you have a road, like circular road like this, from the center to the road, if the length of this radius is r, then length of this whole road will be 2 pi r. And that was an amazing discovery of the old Greeks or Latin. I guess it was Greek who figured that out. The ratio between the diameter, because 2r is diameter, and the circumference of the circle. That was amazing. So tau is equal to 2 pi r over v. Now when you do this substitution, centripetal acceleration is equal to 4 pi squared r over tau squared. Newton's second law, what we are going to discuss in detail later, is F is equal to ma. So centripetal force is equal to mv squared over r. In exam, if you see any question related to that, the formula will be given, and you will be just plugging the values. But what you need to understand from here is what will be the direction of an object moving in a circular path if you just release that. That will be along the tangent. Okay? So that is the most important thing here. That was all about kinematics. Next topic will be dynamics. And I skipped that, so that application, so enjoy that. That will not be in your exam or quiz. This is just for your own study. No class tomorrow, and there is one activity already posted. I guess that is due by Sunday, midnight Sunday, I believe. Let me check Google Calendar. So not Google, Blackboard Calendar. And that's what I told you that, is it tomorrow? Yeah, it is tomorrow. Okay, good. Yeah, so that you don't have time to forget anything. Yeah, the practice for kinematics, that is due tomorrow. And remember, for the intra-block activities in the other blocks, do not rely on Google Calendar as such. Sorry, Blackboard Calendar. But for physics, yes, it is a very nice tool, and use that. So you can see easily the due date. I have started checking the practice sets and trigonometry submissions. Some of you did not submit full assignment. For example, they missed a page or two. For now, I am not taking it too serious. I am granting 100% score if I see noticeable work done. But please be careful in future. You don't want to lose your marks for such silly mistakes. Again, for trigonometry, if you submit, and if I am convinced that you worked enough hard to finish that, I'll grant you 100%. Are we expecting marks for this? Yeah, I'm just discussing that. Let me apologize. I was one of them. It's okay, no problem. First go, it's okay. Not again. Yeah, that's it. And if you have any question, let me know. Me too. I had to pass on a couple. If I'm not mentioning your name, then let's not mention it. A couple questions. Okay. And okay, any question or confusion, please let me know. Okay, then I'm going to stop recording here, and I'll keep the session open for next 10 minutes. If you have any questions, you can ask.